To reiterate, this is 2.1 through 2.5, right? 2.1 through 2.5 are the sections we covered for this. Word problems are coming out of which section? 2.3, okay? You could expect the same format. You could definitely expect multiple choice again. You could expect short answer type of problems again. And then the third part of the test will be problem solving, where you have word problems like the one you had in your quiz, like the ones from 1.8 and 1.9, except instead of equations, we have inequalities. The only difference, so you're kind of getting a second attempt at word problems, especially like just simple linear word problems, except that we're changing it to inequalities now. All right, so this is number 28 on section 2.5. Solve for x in terms of other variables. Assume that a, b, and c are positive numbers. So this is similar to the question we ended with on Friday, right? Okay. So it says the following. Absolute value of x plus c greater than c. Attempt to start this. What do I do when I see an inequality and an absolute value at the same time, Sean? What do I do to start?
You have to split it into two inequalities.
Okay, so I can solve algebraically by splitting it into two inequalities. What do they look like?
X plus c is greater than c, and x plus c is less than c.
So algebraically, this is absolutely the way we want to solve this. I'll go through both methods for this example, just so we can see algebraically and graphically from Friday again. But let's continue algebraically. When I move things around, Olivia, what end up getting here?
X is greater than 0.
And, or in this case, and or, we'll figure out.
X is less than 2c.
Yeah. So again, we subtract c from both statements. Right? Subtract c from both statements. And this is what we'll end up getting. And the question becomes, is it an and statement? Is it an or statement? What's happening here? What's happening here? Can somebody give me an idea as to how this works? And I can accept multiple answers for a reason. I'll tell you what you
So
think.
it was an or statement because since c is a positive number and -2, it would make it a negative number. And if it's greater than 0, they would never cross paths.
Yeah, so based on the actual directions, good point there, I'll tell you. It says, assume that A, B, and C are positive numbers. Without that statement, do we see how this could have actually been interpreted multiple ways? If C were negative, then this is a double negative right here, and as a result, we have x is less than some positive number, x is greater than 0, then that would be an and statement. A good point, and I actually overlooked that. That's why I said there's multiple answers. Good. Since C is positive, this has to be a negative quantity here. So again, x is less than some negative number on a number line. Let's take a look at what that looks like. We've got open circle shaded to the right, and then open circle shaded to the left. Okay, so it's definitely an or statement because we have this jump in the middle, this gap. We call this a disjunction. The or statement is a disjunction when our solution is extending in both directions, left to right. Or left and right. Graphically, how would I start this graphically? What's my process, Nick?
So you start at negative c.
How come negative c and not c, Nick?
Because it's,
What do I write this as?
I would rate it at x minus a negative c.
Yeah, and we talked about how last class we always want to have it in the form x minus some number and then greater than or less than some other number. So we recognize that this some number here in the middle is our starting point. So negative c is absolutely our starting point graphically. Go ahead, Nick, keep going.
And then you do, so negative c is your midpoint. So you
Got
do
it.
negative c on a line.
Mm-hmm.
And the difference between the 2 points you're trying to get to is c. So you add c, which will get you 0, and then subtract c, which will get you negative 2c.
Okay, so again, the midpoint that we're placing here is not actually one of our barriers or boundaries that we're looking at. It's not one of our endpoints for these rays that we're extending outward. Instead, it's just the starting point. That's all it is. Once we've got the deviation left and right, the starting point doesn't actually matter anymore. Okay? The starting point doesn't matter anymore. Now, the tough part about a problem like this is that unless you remember that it's a greater than symbol, you might not know which areas to shade. You can test values in here, and you might run into or you might have a little bit of difficulty. So what numbers could you have? No, plus. What numbers could you have tested? What numbers could you have tested in this case? Over here, it becomes a little bit tricky to figure out what to test. Over here, what can we test?
1.
Yeah, any positive number on the right-hand side, right? If I want to test the point in this region. Now, if I do that, though, let's see what happens. I test the number 1. I get 1 plus c greater than c. Is 1 plus c more than c? Sure it is. We're taking a number like c, any number, and adding 1 to it. 1 more than that number is greater than that number, always. It's saying like 1 plus 5 is greater than 5. Absolutely right, that's true. So we know that we're shading this region on the right. Okay, we know that we're going to shade this region over here. So we have an open circle, and we're shading to the right. Now that alone should tell me that I'm going to shade this region also, because we've only done inequalities so far that are linear. When we get to quadratics later in the year, we'll see that we'll have maybe 3 or 4 different regions to work with. But here, it's either been we shade outward or we shade the middle. It's one or the other so far. So it's going to be the other side here for sure. Let's prove that that's true, though. What number can I test that is less than negative 2c? What can I do? Yeah, negative 3c. That works. And if I plug negative 3c in to see it, I'm going to plug it in so we can actually see this. Negative 3c goes in for x, right? X is right here. That's the x that we're getting rid of. So we have negative 3c, and then it's technically plus c, greater than c. This becomes, if I continue down, negative 2c as an absolute value greater than c, and that becomes 2c is greater than c, and that is absolutely true. 2c is greater than c, so we shade the region that we tested. Remember that when we test a point, if the statement at the end of the testing is true, we shade that region. If we test a point and it becomes false, we don't shade that region. So the middle region, could just test negative c, right? Because negative c is definitely in the middle region. And if I test negative c here, I get negative c plus c. And in this case, what happens if I have negative c plus c? I get 0, right? And then 0 greater than c is not true. Now, the only problem that we're going to run into here for something like this, let me just think for a second. We were told that c is a negative number, right? Oh no, we're told that c is a positive number to start. It can't be a negative number, okay. Because I'm thinking if c could be a positive or a negative number, it would affect our answer, correct? Think about what I'm saying or what I'm thinking about here. If c could be a negative number, then we could run into problems with making the statement true, because then it wouldn't be. If this were negative 1, we have negative 2 greater than negative 1. That would not be a true statement there. So c being a positive number in the directions helps us to actually solve this problem. Without that statement, you can't solve it. The answers would be ambiguous. You can get either direction depending on which way to interpret c. Good, Jimmy. Good question. Definitely a difficult type of question for this test. You can definitely see a question like this, though. You can absolutely see this for the test, but this would be on the higher end of difficulty level. Okay, with numbers it'd be a little bit easier.
I have a question about number 8 on section G5.
All right, same section, number 8. Number 8 says the following absolute value, k minus 4 greater than 1. So what's your question, Altea? Let me start with that. Is it getting to the answer? Is it solving it graphically you had trouble with?
Solving the graph, because my answer didn't make sense.
Gotcha. So this is our starting point right here. We always want x minus c. Remember our standard form in the top right is this. Okay, x minus c is greater than or less than or greater than or equal to or less than or equal to some deviation. So the starting point in this case is 4 and the deviation is 1. So I've got my number line. I go ahead and I put a 4 here. I deviate 1 up, puts me at 5. 1 down, puts me at 3. Again, subtract 1 and add 1 in both directions. I know that it's an open circle above 3 and 5. And since I see a greater than sign, I know already I'm going to shade outward, but I can test the regions to make sure. Try 6. If I plug 6 into the original, I get 2 is greater than 1. That is true. So this region over here is true. I take a number like 2 over here. 2 minus 4 is negative 2. Absolute value of negative 2 is positive 2. Positive 2 is greater than 1, so this region is also true. Does that make sense, Altea?
No, I accidentally made
You see what you did?
-4.
Ah, there you go. Sean.
On the test, will we need to change
If you remember to do the opposite of whatever you see, that's fine. Maybe making a minus. Doesn't matter. Now,
so it doesn't need to be in standard form, so let's say it's w plus 2, we don't need to change it.
no, w minus negative 2. But if you did have something that said like 2w plus 1, then you should definitely factor out 2. You have to do that, and you have to divide both sides by that 2 over the other side.
Can't you just start by dividing everything by 2, or do you have to factor everything out?
Same thing. Yep, that's fine. Because you're in an absolute value, the 2 would come out anyway, so it doesn't matter either way. Yep.
Can you go over solving graphically with a coefficient?
A non-unity coefficient?
Yeah.
Sure. So let's take a look at this one. Let's say we have 3 plus 2x inside the absolute value less than 5. Or let's use, instead of 5, we have 5 in class. Same. Let's say 8. All right, let's say this is our setup here. So we have 3 plus 2x less than 8. So I could start by rearranging the order of the 2, so I can see this in standard form at least. So I see it as 2x plus 3 less than 8. I could recognize that I should take a 2 out, so I have the form x minus something, right? Take a 2 out. So as Sean said, I can divide everything by 2. I want you to see what's happening, so I'm just going to write it anyway. All right, that's what I get when I factor a 2 out. And now, the 2 in the absolute value comes out front as a positive 2. And I can divide both sides by 2, making the right-hand side a 4 there. So that's what this reduces to as a result. And then finally at the end here, what do? I go ahead and I think of it as a minus, so my starting point is negative 3/2, and my deviation is 4. Can I stop there, John? Is that fair? Yeah? And then you would go the rest of the way with the number line. This is your starting point of the number line, 1.5, go up 4, go down 4. It's a less than symbol, so it's going to be an and statement. We're going to shade in the middle region for sure. We can tell that already.
Okay, on the test, would we have to put every single step, or can we skip some? Like,
For example, what step would you have skipped?
taking when you divide by 2 instead of keeping it in the absolute value. And then
Yeah, so you divide everything by 2 right away. That's fine.
Yeah.
Yep, it works.
So just like put everything under on top of the division bar and put it over 2.
Yeah, that's fine. Yeah. Again, remember my policy. Like I'm all about showing work because you can get partial credit if it's not correct. Now, if it's correct and all your work that you really need is there, trust me, I know what you need. I can tell already what certain people need to show and what don't need to show. So if you're not showing any work and nothing is right, you're not going to get any credit, obviously, right? But if you're not showing all the work that I necessarily show, but I know the type of student you are and you're able to skip those steps, that's fine, as long as you're showing enough work and get to the correct answer. So when you're not getting the right answer and you're not showing work, then there's a problem, right? Because then I'm like, okay, well, maybe they need to show their work to see the mistakes along the way to improve in that area. Yeah. Okay, but again, starting point, deviation. This is my starting point right here. This is my deviation right here. While we're on 2.5, any other 2.5 questions? Because we've been on this for a minute or two. That's fine. I just want to ask about that because that's the most recent one. Tomorrow night or tomorrow, your homework for 2.5 is due. So tonight is a good opportunity to practice more for 2.5. Right, your 2.1 through 2.5 problem set was due today, but the homework's not due till tomorrow. Go ahead, Nick, you're up.
I have 2, 4, 20.
2 number 20. Let's see. Absolute value 2t minus 3 plus the quantity 2 equal 5, correct?
Yep.
All right. So this is a good problem to start with because in the quiz, a couple people made small mistakes on this. And this was something that we didn't really go over in class, but we kind of did. So you're going to notice that in like this kind of a course, in an honors math course, that we'll do stuff in class. And then your homework might be a little bit harder at times. You may have to try some things that are a step further, and the same thing with tests and quizzes. So you have to be able to adapt. So if I think back to class, when we studied this topic in class, how did it look different than what you see here?
You can't have the plus 2 at the end.
Correct. We never had anything in class where there was a plus some constant or minus some constant.
Isn't it plus 3?
Is it plus 3?
I plus 2.
No, plus 2.
Plus 2. Yeah, I'm looking at it right now, Sean. It definitely is plus 2. So the same thing over here. What if you have a coefficient in front, right? If you have a coefficient in front, how do you get rid of it? You get rid of it by division. How do you get rid of something that's adding? You subtract it. So just like in class, we got the absolute value by itself, or we started with the absolute value by itself, and then we split it into 2 possible answers. Let's move the 2 over and then take the same approach that we would take. Okay, so moving the 2 over leaves me with 2t minus 3 in the absolute value. and that equals 3. And then I go ahead and I write it twice. The first time, the second time, and then I go through the process of solving these independently. Adding 3 makes this 2t equals 6, and t equals 3. Then over here, adding 3 makes this 2t equals 0, and t equals 0. You can check both our answers in the original. I'm fine with mental checks on these, I really am, but you have to actually make sure you do them. Okay? I'm fine with mental checks on these, but make sure you check your work. Gus?
So just graph something like this, but you just plot 2 points on 3 and 0, because I kind of forgot what the...
Yeah, exactly. Yep. When you solve an equation that involves an absolute value, not an inequality, we can't really graph a shaded region. So we literally only graph a number line with 2 points on that number line, of which those are the 2 answers. Okay? Like that. That's what it would look like on the bottom. No reason I write this in interval notation. It's going to always be written in set notation or with answers like this. If you want to write it with the squiggly brackets, you're welcome to. I think your text loves doing that. A couple of you asked me about that, so you can. And that would look like the following. You would say t equals 0, 3 inside those squiggly brackets, okay? If you want to do that, to run your solution set as 2 points, that's fine. This is more than acceptable right here, what we have. Okay, when it's an inequality involved, I might say answer in set notation, answer in interval notation. So we have to be able to do both of those interchangeably. Jimmy?
Can you go over 2, 3,
Go ahead.
10?
2, 3, this is word problems we're on now. Number 10. Let's take a look. One sec, Sean, hold on. Just give a sec to read it. It says the following: the 3 sides of an equilateral triangle are increased by 20, 30, and 40 respectively. First of all, I know we haven't taken geometry. Some of you have taken like a geometry-esque course in middle school. Equilateral means? All sides are equal. Okay, equilateral, right? Lateral being sides, equi being equal. So we draw something that looks like an equilateral triangle. We can simply label it like this so we know that it's equilateral right away. And then we know that this shape is going to become much larger in certain areas than others. So let's make this x plus 40, x plus 30, x plus 20. Okay, increased by 20, 30, and 40. When I see the word are increased, I know that means plus. It doesn't say increased by a factor, right? Do you understand the vocabulary there? If I said, I'm going to point this out because on tomorrow's test it might look different, right? You have different wording. So if I said that a number is increased by a factor of 3, it means it becomes 3x. But if I said a number is increased by 3, it becomes x plus 3. Again, if it's increased by a factor of 3, the new number is 3 times x. But if it's increased by 3, the new number is x plus 3. And in this case, it said the sides are increased by 20, 30, and 40, not increased by a factor of. So we start with that. The perimeter of the resulting triangle is between, oh, this is interesting, is between twice and 3 times the perimeter of the original. So I'm going to write that statement right here. The perimeter of the new triangle is between twice, so this is, I'm going to say new, twice the old, is it twice and 3 we said, or, yeah, twice and 3. So 2p will be on the other side. Let me explain what I'm writing here. I'm saying that the new perimeter is somewhere between twice the old perimeter and 3 times the old perimeter. Is it less than or less than, or you put it based on the wording? I haven't looked at it clearly.
It's less than because it's between.
Just says between, right? It doesn't say inclusively or anything like that? Good, okay. So it's between twice and 3 times the perimeter of the original or the old triangle. What can you conclude about the length of a side of the original triangle? So what statements can I use here now that I have this statement in front of me? Clark, help me out.
Well, the old perimeter would be 3x.
Agreed?
So you could put 6x on the left side.
Agreed?
And then 9x on the right side of the
Agreed?
inequality. And then the perimeter of the new triangle is 3x plus 90.
Which comes from, right?
Adding all of those, yeah.
Agreed. Keep going, Clark. Yep.
Yeah, you could subtract 90 from both sides.
Subtract 90 from both sides?
Yeah.
Okay.
You could split it into 2 or just.
Yeah, so we have 6x minus 90 less than 3x
Yeah.
less than 9x minus 90.
Mm-hmm.
Okay.
Divide by 3, so then you get 2x minus 30 is less than x, which is less than 3x minus 30. And then you could, well, what I did now is I split it into 2 because that's
Yeah.
what I did.
So let's pause and talk about that. I like that you said that. I was wondering when you were going to do it because you have to do it here. We noticed that? This is the kind of problem that we really have to split into 2 different answers and solve them separately. Like we've talked about this in class, and I said to you guys, you can add 90, or subtract 90 from all 3 terms, get rid of the 3 from all 3. But when you get to a point where you have a variable in all 3 parts, which you kind of did in the beginning anyway, you should definitely be splitting into 2 separate things, right? Because there's no way I can solve this. I'm trying to think unless I'm making a mistake in my own mind. Not really. I mean, if I subtract x everywhere, this becomes x minus 30, and then this becomes a 0 here in the middle, less than, this is going to be 2x. No, right? And I should make this a 30 over here, right?
Mm-hmm.
Not 3. I'm trying to think if there's a way I can do it without splitting. No, I have to definitely split this into 3 statements. I definitely have, or 2 statements, I have to do that. So we have 2x minus 30 less than x, and x less than 3x minus 30. I'll circle it in colors here so we can see the difference. So this is one of our inequalities, and this is the other inequality. Okay? Again, what's in blue carries down here, what's in red carries down over here. What do we get when we solve these 2, Clark?
Well, you could, what I did is I added, or subtracted 2, or wait.
You probably subtracted x on both sides and then added the 30
Yeah.
to both sides, right?
Mm-hmm. So then you get x is less than 30 and 15 is less than x.
Yeah. 15 is less than x. Because you're going to divide by a negative in that case. Is that right?
Yeah.
Olivia?
I did a little differently. I subtracted 3x from both sides. So I had like x.
At what state, Olivia? When you were here?
Like the second step, I guess.
Up here? Right at this point? You subtracted 3x here and 3x here?
Yes, so I had 2 compound statements. I had x is less than 30 is less than 2x, and 1/2 x is less than 15 is less than x.
You got it.
So I took like the 2 parts.
Say it one more time, Olivia. You're saying everything too fast. I can't even write it down. Go ahead. So we move this statement over to this side, move this one over, resulting
It was still at 3x plus 90.
at 3x plus 90, you still did this? So you had a 90 in the middle instead?
Yeah.
Did you eventually split it into 2 parts to solve?
Kind of.
So let's take a look. You had 6x. So she's saying that at this point she was here. She moved the 3x over to both spots to leave the 90 in the middle, which made this 3x less than 90, and that would be less than 6x, like that you had? Okay, continue.
And then I divided like 3.
And you divided everything by 3? Like that? Okay.
And then I divided everything by 2.
You divided everything by 2?
I'm saying from the first statement that x is less than 30, but also greater than 15 because of the second statement.
Ah, so you still have to break it up though. This is one answer, and this is the other answer, like that?
Well, I knew that like from the first one, it was the same as the second. Like from the first part, it says x is less than 30. Like, yeah.
So at this point, what did you say? You said x is greater than 15, and that's this piece right here. Okay. And then over here, this is 15 is greater than x over 2. You move the 2 up to make that x is less than 30.
Well, I didn't have to break it up because I knew from the statement above it was still less than 30 because it's a.
Oh, so once you got this piece, you extracted this information, and then once you got to here, you extracted this information. Okay. Nope, that's fine. You're absolutely right. It works. I wouldn't have thought to do that because I think it's easier to remember to go through the steps of breaking it up. But that works. You see what Olivia recognized that x was less than 30 here, and then she saw this part, inherently taking it apart into 2 pieces in the end. That works. Yep. That works. So our answers are between 15 and 30 pretty much, right? So we can tell that the length of a side of this triangle is between 15 and 30. So when I write this as an answer, I would start with 15 less than x less than 30. And that's in solution set form. So the side length cannot be 15 or 30. It's somewhere between. How would I write this in interval notation? If I were to write an interval notation.
It would be parentheses 15 and comma 30 parentheses.
Yeah. Okay, remember that this looks like a coordinate. It is not a coordinate when we're writing a solution set. If this had been a less than or equal to sign here and here, how does this differ? If these are less than or equal to signs, how do they differ, Gus?
Oh, you put brackets and
Yeah, you put a bracket here to show inclusiveness. If we're including the endpoints, we put brackets here and here. Okay, good problem. Jimmy, was that you that asked that one? And Olivia, good alternate solution there to think about. Very good. John?
So the first one is set notation, and the next one is interval.
Correct. This is called set right here, and this is interval notation right here. And we can do one with an or statement, hopefully, before the end of the period, so we can talk about the disjunction symbol and how that occurs. Other questions you have, though, before I get to that? Other questions? There are a good amount of word problems in section 2-3. Are we confident on those right now? I'm happy to review any others that you struggled with or that you weren't sure of. No, we're good right now? Definitely be ready to use D equals RT, right? Distance equals rate times time. You could use that in a word problem. I think for either homework or problem set, did I give you number 12? Take a look at 2-3. For homework, I gave it to you, I think? Was it homework, Sean, or problem
I
set?
think in class, it wasn't the promise.
Can we go over D over R equals over?
For the homework for
Yeah.
2-5, I think it was 2, not 12.
I gave you, what did I give you? What numbers?
2, just 2.
Just the number 2?
5, I think you just 2. It was just
For
2.
2-3. For 2-3.
2-3, sorry.
For 2-3, did you guys go over number 12 at all, is what I'm asking?
No,
No.
not in our promise set or.
2-4, we had 12.
I did, you know what it is? Did I do 12 in class? Take a look at it. It says during the first 20 miles of 50-mile race.
Oh, yeah.
We did in class. That's why. I'm like, I thought I recognized that for sure. Yeah, Gus, let's quickly talk about that. We'll talk about DT and how it plays a role in a word problem. So I'm going to look at, did you do number 13 for your problem set? Or homework? All right, let's do that one then. So I'm on section 2-3. You have the textbook, right, in your drive folder if you want to look along with it. So I'm on section 2-3, number 13. We'll work on together. It says a subway train makes 6 stops of equal length during a 21-kilometer run. The train is actually moving for 20 minutes of the trip. At most, how long can the train remain at each station if the average speed for the entire trip, including the stops along the way, is to be at least 36 kilometers per hour? So clearly a distance rate problem, right, we're looking at here? So we want to think about this problem as a subway making stops of equal length, right? So I might want to draw a diagram for this. It might be useful for me. So if it's making 6 stops along the way, every time it makes a stop, it says they're equal length stops. So what should I call each stop length?
X.
Yeah, so let's start this with let, and again, this is number 13 on section 2-3, number 13. Let x equal the length of time stopped per station, or per stop. I know it sounds annoying, stop per stop, but yes, the length of time stationary per stop. Not the total sum of them, but each individual stop. And again, we're stopping 6 times, and it's a 21-kilometer run. The train is actually moving for 20 minutes of the trip, so we already know the time moving is 20 minutes. So what's the total time of this entire trip? If it's moving for 21 minutes, and it makes 6 stops, of which each length of time stopped is denoted as x in this case. What do you think, Sean?
1 equals 6x.
So we know that the total time for this trip is going to equal the time running plus the time stopped. And the time that it's actually running for, again, is 20. And as Sean said, we're stopping 6 times. So this is what the total time of the trip is right here. RT yet. I'm using just inspection, just using my, not common sense, I don't use that phrase, it's not common sense, but I'm using inspection, what I see in the problem, to list the total time of 20 plus 6x. That is definitely the total time. Now, we're told that the subway's entire length of the run is 21 kilometers. So there's my distance right there. I'm told, it says it in the first sentence here. It says, at most, how long can the train remain at each station? So what is x, right, is what it's saying. How long can it remain at each station? What is x? If the average speed of the trip is to be at least 36 kilometers per hour. At least 36 kilometers per hour. At least means what? At least means?
36 or more.
Good. Greater than or equal to 36. 36 or more is what I want the speed to be. The problem here is units in this circumstance. What units are these in? What are the units of my time in this problem? Minutes. But what did I just say 36 units were? Kilometers per hour. So I can't necessarily just write this out simply. So I'm going to talk about conversion of those units. But let me start first with the statement that the speed on average, or the rate, right? We've been using R for D equals RT. The rate should be 36 kilometers per hour. My formula D equals RT works, but it only works when my units align with each other. And right now they're not aligning with each other. This is clearly in minutes. If this number were 30 minutes, how many hours is 30 minutes? A half an hour. How'd you do that? You took 30
And put it over 60.
put it over 60, right? Think about that logically in your head right now. When you get to physics, we'll talk more about unit conversion. I'm not going to spend a lesson on that topic right now. But if I think about the fact that I have a certain number in minutes, and think in your mind, how would you convert that to hours? You divide it by 60. So I'm literally going to put that over 60 and write units of hours. So again, this is in minutes right now. I'm going to convert this and write it as 20 plus 6x over 60, and those units are now hours. And I don't have to use this as my time anymore. You see why I'm doing this? Does that make sense? That the rate is in kilometers per hour, so the distance has to be kilometers, and the time has to be hours. And I take a sum of two numbers that are in minutes, divide that number by 60 to put it into hours. And now I can use D equals RT. I can use it as an inequality though, right? So I've got D equals RT. What am I solving for in this problem?
The amount of time, how long you can stop at each stop to.
Eventually, Sean, eventually, but slow down 1 second, you're getting ahead of yourself. It's a little bit more tricky than that, okay?
Are you solving for rate?
Yeah. Why, Nick?
Because you're saying how much time can you stop to make sure it's over 36 kilometers?
We want some number in a statement to be greater than or equal to 36. That was what the actual problem said. What should the time stop be at each station if your average speed is to be 36 kilometers per hour or more? That was the statement that we had. So we need the 36 on the right-hand side somewhere. So I want this rate on the right-hand side. So I'm going to divide both sides by time. And it's not like intuitive to do that. Because normally you'd say I'm solving for x, you plug stuff in, get x by itself, and I get that. But if I want to make the correct statement to start this problem, D equals RT is not the correct statement. D over T should be greater than or equal to 36 is the statement I want to start with. So really, I'm solving this for R, right? I have D over T is equal to R. And then I recognize that whatever D over T is, I want that quantity to be more than or equal to 36 kilometers per hour. And then plug it into this statement here at the bottom. So the setup is the hardest part of this problem, right? All this work to set it up is the hard part. The solution at the end here is not going to be that difficult. Now we're just plugging in. So I've got a distance of 21 over 20 plus 6x. That number is divided by 60, and that's greater than or equal to 36. Now, I can do this two ways, and I know some of you are used to working with fractions well, so you can definitely work with fractions. divide 60 into both of these, this becomes 1/3, right? 20 over 60. And 6x over 60 becomes x over 10. But it still leaves me with a lot of fractions in the denominator, right? It still leaves me with fractions in the denominator. So what could I do instead of dividing both of these by 60? What could I do?
I have a question.
Okay.
Where did the 160 come from?
Where did it's divided by 60, sorry, divided by. I ran out of room, so I used the division symbol that I never use. That's a division symbol right there. Sorry about that part. Gus?
Could you multiply both sides by 60?
Yeah, exactly. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. So in this problem here, when I get to this step here, this is really, and maybe, let me write it a little bit clearer if I can erase. Can I erase this? I can't erase the 60, of course. I'll write it the other way though, so it's more clear. All right, that's really over 60 like that. So when I see it that way, when I see a denominator in a denominator, bump that denominator up to the numerator up there. Okay, so that divided by 60 really means that this becomes 21 times 60 over 20 plus 6x, still greater than or equal to 36. Okay, again, because I divide by a fraction means multiply by the reciprocal of that fraction. This is what it becomes here. I'd have to do a little bit of work here, right? I'd have to multiply these two and move this entire term up to the top right. Sean, what's up?
Wait, wouldn't you also have to multiply 36 by 60?
Now, I'm not multiplying both sides. I'm recognizing that this is division by a fraction, isn't it? And when you divide by a fraction, what should you really be doing? You should be multiplying by the reciprocal. The reciprocal of that number is 60 over the quantity 20 plus 6x. Right? The reciprocal of this is the flip of it. The 60 is up top and the 20 plus 6x is in the bottom. I'm not multiplying both sides by 60. Okay? A little bit more work. 20 times 60 gives us 300. So what do we have? 360 here. Greater than or equal to 36 times the quantity 20 plus 6x. I'd have to go through and distribute, or just actually, we have 36 and 360. That's convenient, isn't it? What can I do on both sides? Just divide by 36, right? If I divide both sides by 36 at this point, it makes it a little bit easier for me. At the same time, divide both by 36, this becomes a 10, this becomes a 1. Subtract the 20. Why am I getting a negative answer? Let me think. Yes, go ahead, Nina.
You get 360 because you went from 21 times 60 to 360.
That's why, clearly.
Makes sense.
21 by 60. 20 times 60 is 1200. 1260. Thanks, Ina. I said 300, and then somebody said, yeah, 360, so I kind of went along with it. 1260. So 1260 over 36 we have to do now, unfortunately, huh? All right, well, on your test tomorrow, you'll be given calculator on a part, calculator on no part. If it's a part where you have this much math work and you're multiplying, I'll allow you to use a calculator on it just so it's quick as you go through it. Okay, but divide by 36 into 1260, what do we get for that?
35.
35? Now the answer makes sense. Does everybody see why I stopped there when I had a 10? Remember I talked about sanity checks? I talked about making sure your answer makes sense. At one point, when we had written here, instead of 1260, we were written 360, this became a 10. And then when you subtract 20 from 10, it becomes negative, which would have given you a negative x, which is a negative time. And that doesn't make sense logically. That was the point of stopping. And you said, you're crazy, it's 1260, not 360. And that makes sense now, because now when we take the 20 away, we get a 15. Right? And we get 15 is greater than 6x. And now the answer makes sense. Divide by 6 on both sides, we get 2.5.
Yeah.
So x must be less than 2.5, less than or equal to. So at most, we can stop up to 2.5 minutes per stop on the train. Anything more than 2.5 minutes, your average rate will no longer be 36 kilometers per hour or more. So if we stop for 2 minutes and 40 seconds, we're not good to go. 2 minutes and 30 seconds just makes it, right? 2 minutes and 30 seconds just makes it. Yes?
Where do you get, you see 1260 is greater than or equal to
Yep.
36. Where do you get the 36 from?
This?
Yeah.
From here.
Oh, then
I multiplied this up onto this side, right? Because this is,
multiply 36 by 20 plus 6.
yeah, but I didn't want to do all that work. I'd have to distribute and then redo it. So I just divided both sides by 36 now. And I did 1260 divided by 36 to give me 35. Okay? Sometimes distributive property isn't actually useful, especially if you're solving for something that's inside of here. I recommend just dividing by the coefficient and getting rid of that first and then solving. It makes it easier. The numbers become smaller. Okay? Okay? No? A long problem, right? A lengthy problem. This would definitely be a challenging problem for the word problems. This would definitely be the higher level challenging problem. Clark?
I was going to ask if this would be one of like the toughest words.
Yeah, it would definitely be one of the tougher word problems. So if you can keep up with this, that'd be the extent of which you'd see a D equals RT problem. Others on 2.1 to 2.5. Trying to think of what else. 2.1 was pretty simple because 2.2 we built on, right? From 2.1. So if you can do 2.1, and if you can do 2.2, 2.1 is actually just a kind of a review of 2.2 with a little bit more work. We combine the inequalities.
These are hard copy problem sets.
Thank you. And I think I have one more on my desk somewhere.
Okay,
Take a look. Did you do Warsaw's electronically, or is that hard copy? Yeah, I think he submitted both. Because I have a hard copy on my desk, but I think he did electronic also. Thanks, Steve. 2.2, 2.4, 2.5. Trying to think of other examples. Olivia, go ahead.
Can you just go over
2.4.24, sure. 2.4.24 says the following. 6 plus 5 times the quantity, absolute value of 2r minus 3 is all greater than or equal to 4. Yes? Correct? Okay. So we're subtracting 6 to start right away. We subtract 6 to get rid of it. We divide by 5. Now, we stop and the problem's over. Why? How is the problem over at this point, Sean?
Because as long as it's in an absolute value sign, it will always be greater than a negative, so it has infinite solutions.
Anytime this happens, good, thanks, Steve. Anytime this happens, write it down, that you have an absolute value of something with a variable in it, and it's greater than 0, or greater than or equal to 0, or greater than or equal to a negative number, the answer is all real numbers. It's always going to be all real numbers, because no matter what you try for r, this quantity is positive, right? And it's always greater than or equal to a negative number. Always greater than or equal to a negative number. What if it had been the opposite? What if it had been less than or equal to? Is our answer ever going to be less than or equal to a negative number? So the answer is?
No
No solution. No solution for that. There are certain problems that you can stop and just literally write, this will always be true, therefore all real numbers. This will always be false, therefore no solution. Okay, so tonight I would recommend simply just practicing extra problems. I would personally, for me, look at word problems. I think those are the parts of the test that students struggle with the most. So I would look at additional problems in here, or I would even look up Google online. Inequality, one variable word problems. I guarantee you'll find a slew of them to practice tonight. Okay, make sure again that the 2.5 homework is turned in tomorrow.
That was one of the
No, I didn't.
I would recommend looking at some of the homework.